Hello and welcome to Rails tutorial. Today's topic will be about force and translational dynamic. This is a new topic. The last time we worked on kinematics, now we're working on force. And we'll focus on many details on force and translational dynamic. So please like, share, comment, and subscribe to the YouTube channel. Now let's dive in. What is force? Let me talk about force. It's when force has to do with two objects' interaction. It's either the object is being pulled or it's being pushed. This is when force occurs. If an apple falls from a tree, it falls to the ground. So if you push a crate, you move it. So that push makes the crate to move, causes that motion for the crate to move. So if an apple falls on the ground from a tree, the earth will be exerting a downward pull called gravitational force. Because if an apple here falls down from a tree, and this is the earth is exerting a down pull called gravitational force. This is a down pull called gravitational force. When you stand on the floor provides an up pull. When you stand, it's a human. When you stand on the floor provides an upward force called normal force. It's an upward force called normal force. When you slide a crate across the ground, this is a crate, and you slide this crate across the ground, the force exerts a frictional force. This is the force of friction against the crate. This is force of friction against the crate from the ground. So whether a force is an action at a distance force, like gravity, or a constant force, like pulling a door handle, its effect on the object is described by Newton's law. So however the force is being applied, the effect on that object is described by Newton's law. So let's look into it's about force. So look at the subtopic that we're going to be diving in. So in this force, we'll look at the Newton's law of motion. That's the first law, the second law, and the third law of motion. We'll also focus on the weight and normal force, the friction, pulling, and inclined plane. Okay? So, but for today, we'll look at the Newton's law of motion. So the first law of motion states that an object will continue in its state of motion unless compelled to change by a force impressed upon it. That means a car moving on a straight line, a car starts from here, moving on a straight line, will continue to move on that straight line unless it's been affected by another object. Boom, they need to change its motion. That's what this implies. The object's natural resistance to change in their state of motion is called inertia. So when an object is in a state of inertia, it's when an object is just moving without any distortion. But the Newton's first law of motion states that an object is being in a state of or continue to be in a state of its inertia unless it's a force is applied upon it. So an object continues to be a state of inertia unless a force is applied upon it. That is what the Newton's first law of motion states. And this is Newton's first law of motion is called the law of inertia. So we stated that in summary, the Newton's first law of motion states that an object will continue to be in a state of motion unless compelled to change by a force impressed upon it. Okay, so let's look at some of the examples from this law. From the first law of motion here, so now we're looking at what is the net force? What net force is required to maintain 500-kilogram objects moving at a constant velocity of magnitude of 7,500 meters per second? What's net force? So we're looking at what is the force required to maintain an object of 500 kilograms moving at a constant velocity. So remember that the Newton's first law of motion states that an object will continue in a state of motion unless an unbalanced force acts on it. Therefore, there is no net force required to maintain this object 500 kilogram moving at the constant speed of this. So in this case, the force here is equals to 0 because no force is required here because the object is just moving at its constant speed of that. So there's no force required here. So if no net force is needed to keep the car moving at the constant speed, why does the driver need to press down on the gas pedal in order to maintain a constant speed? There's a big difference between a force and a net force. As the car moves forward, there is a frictional force. As the car moves forward to the car, as the car moves on the road, there's a frictional force opposite the opposite the direction of the motion that will be slowing the car down. This frictional force here. The gas supply energy to the engine to spin the tire is exert a forward force on the car to counter friction. So when you apply the acceleration, it counters the friction on the road to make the car to move faster. So in this case, there is no net force. There's no net force applied to this question. So just for a summary, if an object is experiencing zero acceleration, that is, the velocity is not increasing or decreasing, then the object is experiencing zero net force. Okay? Since here there is no change in velocity, the velocity is constant. So, and when you remember when its velocity is constant, acceleration is constant, right? So in that case, the force is equals to what? 0. The Newton's second law of motion states that acceleration A, acceleration A will be directly proportional to the strength of the total or net force and inversely proportional to the mass m. So acceleration A is directly proportional to the force and inverse proportional to the mass. So net force here will be mass times acceleration. And the unit of this force is called Newton. It's written as kilogram meters per second. So when we have acceleration, it will be equals to force over the mass. As F is the force, M is the mass, and A is the acceleration. Okay? Let's look at an example to calculate this. Now, this example. How much force is required to cause an object of mass 2 kilograms to have an acceleration of 4 meters per second square? So we know that from the previous question, it says acceleration is equals to force over mass. So now we're looking for how much force. We're looking for the force. So force is equals to mass times acceleration, which is the mass here is 2 times acceleration is 4. So that is the force applied for that question. For the third law of motion, states that for every action, there is an equal and opposite reaction. So if an object 1, if an object 1 exert a force on object 2, and this is object 1 and object 2, exert a force on object 2, then object 2 exert a force back on object 1, which is equals in strength but opposite direction. What this means is this is object 1 and this is object 2. If an object 1 travels this way, and object 2 is also traveling this way, and as a collision, the object 1 hits object 2, pam, pam. They have equal strength, they are equal in strength, but they're moving in opposite directions. So with this hit here, when these two balls hit each other, it will make them move in opposite reaction. So this object 1 might make object 1 travel back in this direction, and object 2 travel back in this direction too. It is the opposite in direction. They may have equal strength, but opposite in direction. Because an object is coming, let's say 2 cars are driving, a car is driving to the left, another car is driving to the right. Once they hit each other, they are equal in strength, but they're traveling in different directions. So that heat up is also like motions. That's what third law of motion explaining. So every action, there is an equal and opposite reaction. Okay. Now let's look at an example to this. An object 1 exerts a 300 Newton force to the right of an object 2. Both objects are stationary. What is the force that object 2 exerts on object 1? So now, from the third law of motion, that states that from object 2 on object 1, third law of motion states that the force from object 2 to object 1 is equal in magnitude but opposite in direction. It's equal in magnitude but opposite in direction to the force from object 1 on object 2. Therefore, object 2 exerts 300 Newton force to the left of object 1. Okay? So the object 2 exerts the same force to the left of object 1. Because if these objects are both in stationary, like mentioned, and object 2 exerts a force to the right of object 1, then object If object 1 is at a 300 force object to the right of object 2, then object 2 also exerts the same 300 force to the left of object 1. The motion of the object is irrelevant. The third law is concerned with individual force acting on an object, unlike the first and second law that deals with net force. So the motion of the object is not relevant. It's just the force, individual force. That is what the third law is all about. So let's recall what we've studied today about the Newton's law of motion. The first law states is talking about moving stuff. First law talks about moving stuff keeps moving. Rest stuff keeps resting. The law of inertia, that is, the object naturally resists change in their velocity, and measures of inertia is mass. But the second law is the net force is equal to mass times acceleration, whereby the force are vectors. Then the unit of of force is Newton, that is in kilogram meters per second square. And the third law states that for every action and reaction pairs, force of 1 is equal to the negative of the force of 2. The forces are equal but in opposite direction. Okay, so always remember that. These are key points. All right, so this is the end of today's video. Please like, share, comment if you have questions, comment if you need me to improve some more, and please subscribe to the YouTube channel. Thank you. I'll see you in the next video.